So hi guys, welcome back. So this is video 2 for the estimation of formworks. Okay, so we're already done estimating the formworks for the footing. Okay, so not now, we are now going to proceed with the column. Okay, but we're not going to consider the column for all the level of the houses. So we're just going to focus first on the column below our natural grade line, because if we're going to do the construction, it would be from the footing, column, grade beam, slab, then the column for the first floor. Okay, so that would be the arrangement during construction. So right now we're just going to consider the column first below the natural grade line. So let's consider this isolated footing, no? Because I think this is the best example. Okay, so this isolated footing, we have a depth, we have a height for the column of 0.9, but that would not be the final height of the column yet. Okay, so we need also to consider the grade beam and the slab on fill. So going back to the elevation, so this is the elevation. Okay, so this is the elevation. So the natural grade line is elevation 0. Okay, so the natural grade line is the elevation 0. Therefore, the first floor line is equivalent to elevation 0. So we need to consider here the slab on fill, which has a thickness of 0.1 meter plus the grade beam. So what is the depth of the grade beam? So going back to the schedule, the grade beam is also equivalent to the primary beam, which has a depth of 0.4. Okay, so 0.4. So the height that we're going to consider here below the natural grade line for the column would be 0.9 minus the thickness of the slab on fill minus the depth of the grade beam. Okay, so redrawing that, it would look like this. Okay, so the height is from the natural grade line is 0.9 meters minus 0.1 for the slab thickness, slab on fill, minus 0.4 for the depth of the grade beam, and that is equivalent to 0.9 minus 0.1 minus 0.4. 0.4. Okay, 0.4 meters. Then we can now start estimating. Okay, so given the dimension of 0.4 times 0 by 0.2 and 0.4 meters. Okay, the dimension of the column, which is C1, is 0.2 by 0.4 by 0.2 by 0.4. Okay, so that would be the inner diameter. Now for the forms, okay, the first thing we need to estimate, by the way, is the forms. We simply need to get the area for the forms. So that would be 0.2 plus 0.4. Now, take note that on these two sides, we need to extend at least 0.05. For the bracing, isn't it that we are using 2 inch by 2 inch for the bracing? Yeah. So we need to extend here 0.05, 2 inches 0.05. Also here we need to extend 0.05. Why is that so? Because if not, we're not going to extend 0.05 and 0.05. We will only be stopping at 0.2. And we also have here 0.4. Then if you're going to imagine that, it would look like this. Okay? So it would look like this. Then we cannot connect our formworks. But if we're going to extend, we're going to extend 0.5 here by 0.5, then it would be easier for us to connect our formworks on this portion, on this portion, on this portion, and also on this portion. Okay? Therefore, the total dimension on one side, on the extended side would be 0.2 plus 0.05 plus 0.05. Okay? So, the area is equivalent to 0.2 plus 0.05 plus 0.05 times 2 plus 0.4 times 2. Okay? Then multiply the whole equation by 0.4, which is the height. Okay? So I repeat, it is 0.2 plus 0.05, which is the extension, plus 0.05, which is the another extension, times 2 because there are two sides, plus 0.4 times 2 because there are two sides. And this is the perimeter. Now to get the area, just simply multiply it by the height of 0.4. And the height is equivalent to 0.2 plus 0.05 plus 0.05 times 2 plus 0.4 times 2 times 0.4. The area is 0.56 square meters. But we're not yet done there. We need to count how many C1, F3 are there. Then we're going to multiply to get the total area. So the total area is equivalent to 0.56 square meters times the number of C1, F3. So going back to our foundation plan, we just simply need to count how many C1, F3 do we have. So we have 1, we have 2, we have 3, we have 4, and that's it. So we have 4 for C1, F3. So the total area would be 0.56 times 4 pieces. And that is equivalent to 2.24 square meters. Okay? To determine the number of plywood, we simply divide the area of 2.24 divided by the dimension of the commercial size, which is 1.2 times 2.4, and that would be 2.24 divided by 1.2 times 2.4. And that is equivalent to 0.78 pieces. And that is equivalent to piece of one piece of 4 feet by 8 feet by 1/4 inch. But in your case, you should not round it up yet, because take note, based on our floor plan, we still have C1F1, we still have C1F2. So you need to add all of them before rounding up to your whole number. But for the sake of computation, we're going to round it here. Okay, so we can proceed with other estimation. Okay, so yeah, next would be number 2. We have, after the forms, next is bracing, or for the brace. Again, we're going to use the dimension. We're going to use 2 inch by 2 inch by 14 feet for the commercial size. And the factor for 2 inch by 2 inch by 14 inch is 4.67 board foot per piece. Now, how many 2 inch by 2 inch by 14 feet are we going to use for the forms, no? For this 4 column. And that would be the area total, total board foot, is equivalent to 2.24 square meters times 12.71 board foot per piece. No, not per piece. Per square meter. So square meter will simply cancel out. Therefore, the total board foot is 28.47 board foot. And we round it to the whole number. And that is 29 board foot. Okay? Again, if you're estimating it, do not round it up yet to the whole number unless you're already done estimating for all the column. But for our case, we're going to round it up already, so we can proceed with the computation. Okay? So for the number of 2 inch by 2 inch by 14 feet, we simply divide 29 board foot by 4.67 board foot per piece. Board foot will cancel out, therefore 29 divided by 4.67, that is 6.21 pieces. So that is equivalent to 7 pieces of 2 inch by 2 inch by 14 feet. So 29 divided by 4.67 is 6.21, and that is equivalent to 7 pieces. So we will be using 7 pieces of 2 inch by 2 inch by 14 feet for these 4 columns. Okay? For C1F3. So after determining the number of plywood and the number of rough lumber for the bracing, we are now going to estimate the scaffolding materials. Okay? This time we will be estimating the scaffolding materials because it is no longer it is not like the footing that is suspended on the ground. This time it is already erected. Okay? So there is a need for a scaffolding. So if this is your column with the bracing, we have here your horizontal scaffolding. We have here your vertical scaffolding. And you have here your diagonal scaffolding. Okay? Now for scaffolding, we are going to use 2" by 3" by 14 feet. So take note, we are going to use 2" by 3" unlike the bracing that it is only 2" by 2". This time, it is 2" by 3". This is for stability purposes. Okay? So, in estimating for the scaffolding, it would be difficult if we're going to use the direct count method. So, with the help of the book of Fajardo, which is this table, it would be much more easier to estimate rather than doing the direct count method. So this time it would be by area method. Okay? So since we are using the 2 by 3 size, it would be for the column, take note, we are estimating for the column scaffolding. It would be for the vertical 7, for the horizontal 31.67, but for the horizontal we're going to divide it by 2 because this is quite big. And for the brace or the diagonal, it would be 17.50. Okay? By the way, it is not per square meter, it is per meter height, or for per meter length rather. Okay? So we have here, going back to our first diagram, isn't it that the height that we were able to compute is 0.4? Okay? So for the scaffolding, for the scaffolding it is the meter height. Okay? So what would be the total height? So the total height would be 0.4 times how many C1 for F3 do we have? So we have 4. Okay? So it is 4. So 0.4 times 4, and that is 1.6 meters. Now, using the factor for the 2" by 2". So, 2" by 3" for column, it is 7 for the vertical, 31.67 over 2. For the horizontal, and for the bracing, it is 17.5 for the bracing. Okay? So for the board foot total, that would be 1.6 meters times vertical, horizontal, bracing, or diagonal. So that would be 7 plus 31.67 over 2 plus 17.5. And this is board foot per meter. Meter will simply cancel out. And that would be 1.6 times 7 plus 31.67 over 2 plus 17.5. And that is 65.57 board foot. And that is equivalent to 66 board foot. Okay? So we will be using, again, like what we have said a while ago, 2" by 3" by 14 feet. Now, how many board foot does one piece of 2" by 3" by 14? So that is equivalent to 7 board foot per piece. So the number of 2" by 3" by 14 feet is equivalent to, what is the total? The total is 66 board foot divided by 7 board foot per piece. Board foot will simply cancel out. Therefore, the number is 9.43 pieces. And that is equivalent to 10 pieces of 2-inch by 3-inch by 14 feet of rough lumber. Okay? Therefore, for the scaffolding of these 4 columns, C1 for F3, it would be 10 pieces of 2 by 3 by 14 feet rough lumber.